Hey folks, this week Aaron Newcomb joins me and we talk with Piers Finlayson about One ROM. It is a ROM replacement open source project for basically anything based on the 6502. So we're talking Commodore 64, even the Commodore PET, other systems from that era. We ask a lot of, I ask a lot of dumb questions and Aaron asks a lot of really good questions and we get to learn all about the project. You don't want to miss it, so stay tuned. This is Floss Weekly, episode 850, recorded Tuesday, October the 7th. One ROM to rule them all. It's time for Floss Weekly. That's the show about free, libre, and open source software. I'm your host, Jonathan Bennett, and today we are talking about, well, something I don't have a whole lot of experience with. That's retro computing, retro hardware, and sort of mashing together new things and old things. We were talking before the show, and my experience with retro hardware is basically limited to the fact that I'm just old enough that when I was a kid, we had like a 386 and a 486 machine, and I had some hands-on experience with those. That's basic. I had a cousin that had a Commodore 64, and so I got to mess with that a few times, and that is basically my experience with retro computing. And so when we had this particular topic, the One ROM, come up, I went, I know a guy, and that guy is Aaron. Welcome to the show, sir.
Hey, thanks for having me. Yeah, I'm super excited about this one.
Yeah, this was the One ROM from Piers was kind of already on your radar when I sent you that email, and you're like, yeah, let's do it. Yeah, I'm totally up for it.
Yeah, the timing was perfect. I really had just started digging in deep to Pierce's project and the kind of things he's building. And yeah, this does, we should say this is also open hardware as well. So it really does fit in with Floss Weekly from a number of angles. From a number of angles. All the ankles are here. But yeah, this is a really exciting project, and it's really pertinent for people that do want to relive their childhood for computers, especially that are maybe a little older than a 386, going back into the Commodore 64 days, because what's happening is it's getting difficult to find some of those ROMs, right? And that's where you store the information that you need to boot up the computer mostly, or to sometimes contain the character sets that would come up on those old computers. They would be stored in ROMs. They would be programmed, and those chips would be in your computer. And if those go bad, then you're kind of up a creek. Now you can still find them. If you're like me, you go to eWaste every week, and when you find an EEPROM chip in an old motherboard or something that maybe was for some controller system or something, but it still could work, you pry that sucker out and bring it home with you. But not everybody can do that. So yeah, we're going to be talking about a project that aims to solve that scarcity problem today.
Yeah. Well, let's go ahead and hit the right buttons here, and we'll bring Piers on. Welcome to the show, sir. So glad to have you.
Thank you very much. Great to be here.
Yeah. So how terribly wrong did we get it? What is the One ROM? Can I run it on a 386?
Not yet.
Okay. Not yet.
Between you did really well.
Okay.
But perhaps I'll give you a bit of background how I got to One ROM. It'll also make a lot of sense to people. About a year ago, I got into the hobby of collecting retro systems. And my idea of retro systems are really, I was a Commodore guy as a kid. So I started collecting Commodore 64, VIC-20, Commodore PET, and in particular the disk drives. And I found I have a huge affinity for the big chunky old disk drives that these systems used. All of these systems are processor based, and they have ROMs, as Aaron said, to store the code on them that the CPU is going to boot from and needs to run from. And anyone who gets into the hobby of collecting retro systems, again, as Aaron said, needs to be prepared to get their hands dirty, and they're going to need to fix some things from time to time. Often these systems were stored in suboptimal conditions, humid or damp conditions, and there's a bunch of rust and some chips have gone bad. And I found myself quite often needing to replace the ROM chips. And while superficially the ROM chips in these different devices all look the same, they're not. They have different capacities, and they also have other different hardware properties, like the number of chip select lines on a ROM differs between the different models. Now, the chip select line, for the uninitiated, is how the CPU indicates to a ROM that it should actually do something. The CPU activates the ROM chip by activating the chip select line. And different chips have different numbers of those, and they can also, sometimes they're active high, given a digital logic level high, sometimes they're active low. And I found myself having to have lots of different hardware solutions to try and replace ROMs in all of these different systems. And one day I just had this thought, hey, can I do this in software? Can I use a modern microcontroller and just, implement all the different behaviors and ROM sizes and so on, and have a single PCB, a single microcontroller based solution that will do everything? So that's really the aim of One ROM, is to be the most flexible replacement ROM for your retro systems, that you have one PCB, it can support all these different systems, and because it's microcontroller based, you can make it really easy to program. You don't need like a $50 EEPROM programmer to program the device. And you can also implement other capabilities on it that people would never have even thought of back in the day. And I guess we might get onto some of that later in the show.
Yeah. So I'm going to leave the camera on you for just a second, because I looked up and I see an Apple II, a Commodore PET, I think, and then is that a Commodore 64 on your other side? Like, that's quite the collection.
So over there is an Apple Mac Classic, I think it is. I've got a Commodore PET here. Behind the PET, there's some dual disk drives that worked with the PET. There's some more disk drives over this shoulder, and then I've got a Commodore 64 and a VIC-20 hiding behind me. As I said, I'm mostly a Commodore.
That's great. As I alluded to earlier, I don't have any classic hardware like that. I think that the oldest thing.
I'll hook you up, Jonathan. I'll hook you up. You tell me what you want, I'll send it to you.
Oh, well, okay.
The really embarrassing thing is, I grew up with these machines and then I ditched them. I sent them to E-Waste 20 years ago and I want them back, but you have to buy different ones now.
Yeah, I've heard that. I've heard that from many people. And sometimes it's, you grow up and your parents tell you it's time to get rid of this old hardware, or you get married and your new spouse tells you it's time to get rid of this hardware. And then 20 years later, it's like, why?
Yeah, exactly.
Yeah. The beautiful thing about it, though, now, especially for me, is you get to, you get a little older, you get a little bit more disposable income. Mm-hmm. You turn this into your hobby instead of maybe buying a boat or something. And, it sounds expensive, but you can really go a long way, collecting these systems. And for me, it's like, oh, yeah, I used to go over to my buddy's house and he had a Commodore 64. Mm-hmm. And I never really got to explore the depths of it. We just played some games on it or whatever. Oh, now I can actually get that system and explore it myself. Similar to game systems, people collect these old game systems. It's like, well, I had an Atari, my buddy had an Intellivision. Now I can have the Intellivision too, and kind of explore, what it's like and really put it through its paces. So it's a fun hobby. I think it's a reasonably accessible hobby, but we are talking about 40-year-old equipment that they never designed for it to have a 40-year lifespan. So this stuff does go bad all the time.
Yeah.
Yep.
So the One ROM, how similar is that to modern EEPROMs? That's what I have experience with doing embedded stuff. Is it basically the same idea? Can you use an EEPROM with an adapter? Is that what you're doing?
Yeah, no, that's you can absolutely do that, and you can differentiate between EEPROM and EEPROM. So some of these solutions are using EEPROMs, which were erasable programmable read-only memories, and to erase those you need a little UV light box, and it has a little window in the top, and you shine UV at it for a few minutes to erase it, and then you can program it with one of these $50 programmers. Then there's EEPROMs, which are much more modern, and you can actually buy. They're still being manufactured today. And you can erase them electrically with the programmer, and you can program them with the programmer. But it's kind of a static thing. Think of it as literally a blob of read-only memory. And that is then just, it's being sent some signals on address lines indicating which byte to serve, and one or more chip select lines saying you should be active now and actually serve the byte that's at that address location. And then it has data lines. And it sets those data lines to the correct bits to serve that particular byte. It's a very kind of, I don't want to make it sound stupid, but it is kind of a dumb device, right? You just you give it signals on its pins, and then it sends other signals out of other pins.
Well, so on like a modern EEPROM, sorry to cut you off, but on a modern EEPROM, we would talk about like I2C, I2C interfaces, or a SPI bus. On the legacy hardware, the stuff that you want to support, it's a bit different sort of busing, isn't it? We're not they didn't have I2C. They probably didn't have serial buses at all for these, did they?
No, correct. It was literally just you have these address lines and you have the data lines, and then you have more and more chip select lines, and there's generally a shared address bus and shared data bus. So you have multiple ROMs and potentially RAM chips and other things, and potentially multiple controllers, right? You might have a CPU and a video chip that can control all of the ROM and RAM chips in your device, and they're all sharing the address bus, they're all sharing the data bus, and they're all sharing the chip select lines. So it's really important actually that only one device serves a byte at any one point in time, or you'll get a conflict and the system will end up crashing. So yeah, it was a pretty simple mechanism that was used, and it involved a really intricate dance between all the different components in the system. With these, Commodore 64, there's actually an awful lot going on inside it, despite the fact it's 45 years old, nearly 45 years old at this point. And I'm kind of still in awe of the engineers getting everything working together without the cheap and accessible, oscilloscopes and other equipment that we have today.
Yeah, one of the interesting things about sort of looking into the way the Commodore 64 and those other systems worked is whereas today we have system on chips, SoCs, where everything is on one die. And so, you've got, in some cases, your CPU, your memory, your video chip, and you've just got some GPIOs and some serial buses, and that's it. Whereas with the Commodore 64 and the older ones, everything was sort of exploded out, and you would have individual discrete chips. And I think that's part of why people like these so much, because you can actually look at it and go, there's the video card, and I sort of understand what it's doing. There's the memory chip. There's the ROM, and you can actually trace the buses. And so you can buy, you can get an oscilloscope or a logic analyzer and actually watch the data go back and forth. Which on a modern machine, I mean, good luck. You gotta $10,000 and delid the die and all kinds of other crazy stuff to be able to try to see that. I think that's part of why people like it so much, is because it's a small enough and simple enough system that you have some hope of being able to understand the whole thing.
And you can learn an awful lot from it that's still relevant today about how computers work.
Absolutely.
My kids are quite excited watching my YouTube videos, and I think it's actually really educational for them, understanding how these systems work, and also teaching them skills like you don't need to be afraid of technology. It's not actually magic. It's physics and stuff you can learn and you can understand, but it's quite an accessible way of getting into the hobby rather than looking at a 12th gen Intel CPU, which, well, frankly, good luck with that.
Right. Okay, so the One ROM. What all hardware, what systems do you support with it? So we've talked about Commodore, but I assume there's some others.
So what I've tested with is mostly the Commodore stuff. So, the PET, the VIC-20, the Commodore 64, the disk drives. It's been tested by other people on TI-99, Texas Instruments system, Coco 2, and I would guess a whole bunch of other systems, but people haven't told me about. But most machines actually from this vintage, around about late 70s and early 80s, tended to use the 23 series ROM chips, which are 24-pin ROMs that are 2 kilobytes, 4 kilobytes, and 8 kilobytes. So on the face of it, One ROM can support a ROM chip in any of those systems, any machines of a similar vintage. I actually have an Atari 800XL that arrived from eBay the other day that I want to test One ROM in. But I've also got some really interesting conversations going on GitHub with people who want to use them in keyboards, synthesizers from the same generation because they had the same ROM chips, and also pinball machines. Now, I have a few pinball machines myself, but they're more of your vintage, Jonathan, the 1990s and beyond. But the late 70s, early 80s pinball machines, again, used the same ROMs. And I've got some people very interested in trying out One ROM in those systems as well. So think anything from that sort of vintage, late 70s, early 80s, is One ROM's, sweet spot.
And I should add that it people probably intuit this automatically, but especially that series, the 2300 series of ROMs, are difficult to find. So I can still, like I said, I'll go to eWaste, right? And I can still pull out some ROMs from later series pretty easily. You can find, and those are larger ROMs. They support 512 K of ROM space, right? So you can find those later ones pretty easily, but they're not the same as the 2300 series. And so what people would do to get around that problem of, oh, I can't find this, is they would make adapters to put the newer style ROMs into the older, to make them compatible with those older ones so that they could put those in their computers. And that is a whole fussy mess kind of in and of itself. So, so there's all these workarounds that people have been doing historically to try to make this work because they just can't find these anymore. And that's becoming more and more the norm, especially with Commodore stuff, right? The SID chips, there's lots of people that make SID replacements. The VIC chips, I mean, these were all proprietary chips that MOS made for Commodore, since they were owned, because Commodore owned them, they could say, go make this chip. But when those go bad, they're super hard to find, and the ROMs are kind of in the same boat, although not quite as bad as those chips. But those 2300 series ROMs are hard to find.
Well, and it also depends on it. Sorry to cut you off, Aaron. It kind of depends on the 2300 series chip you're talking about, right?
Yep.
The dual disk drives that work alongside the PETs, actually, while they might have 4 kilobyte 2300 series ROMs in them, they're not the same as the 4 kilobyte 2300 ROMs in a C64, and that's not the same as the one in a VIC-20. They have different hardware behavior that was programmed at the factory, and you find yourself with like lots of different adapter boards with different configurations on them for each of these different replacements. And that was the problem that really led me to think, I need one thing. I don't want to have 14 or however many different adapters for this solution.
And how are you getting around this is one of the questions I had, is how are you getting around the voltage requirements of these chips? Because I don't remember exactly, but isn't there like a 12 volt or a negative 12 volt on some of the 2300 series? But modern chips usually run on like 5 volts or 3 volts. So how do you make that work?
So not on the 2316, 2332, and 2364, the 2, 4, and 8 kilobyte chips that I'm replacing. There's no negative 12 volts. Now, there is on, I think it was on the Apple 1, possibly on the early versions of the Apple 2, one of their character ROMs did have minus 12 volts fed into that. Yeah. That's actually got a different pin out to the regular 2300 series ROM. So One ROM doesn't support that today. There are solutions for that, but you would need an additional hardware on your PCB to filter that out and not fry your electronics. But honestly, the voltage is actually a great topic, because these systems are all running on 5 volt logic, and if you want to have a replacement ROM solution that's the same footprint as the 2300 series ROMs, it has to be really small, and you can't afford, particularly on a cheap 2-layer PCB with components on one side, which is what I was trying to achieve. You can't afford to have level shifting ICs, because you need to level shift like 22 pins. You just can't fit that on the PCB. So one of the key decisions I had to make when developing One ROM was to find a microcontroller that was 5 volt tolerant natively, because most of them are powered by 3.3 volts. That's fine. You can stick a tiny voltage regulator on One ROM to give you 3.3 volts. But the GPIOs have to be capable of receiving 5 volts, and the logic levels that the microcontroller is going to apply for digital high and digital low have to be compatible with these retro systems. That's why in the first release of One ROM I went with the STM32 microcontroller, because it had native 5 volt tolerant GPIOs, and in fact the maximum absolute voltage on those is 7.3 volts, which is plenty for these systems, because even with a dodgy voltage regulator, it's probably not getting up to 7.3 volts, and if it is, it's probably fried more than One ROM. But then in a subsequent release of One ROM, I actually added RP2350 support, so the Raspberry Pi microcontroller that's in the Pico 2, because that does advertise native 5 volt tolerant GPIOs that don't require level shifters. Having said that, there are some caveats and gotchas in the RP2350. I
was going to say,
tolerance support.
I noticed you used the word advertised there. That seems like that was carefully chosen. These are all clear in the datasheet. The datasheet is clear that it's 5 volt tolerant on its GPIOs if you have 3.3 volts applied to VDD, powering the chip, by the time you put 5 volts on one of the GPIOs. In an application like this,
I don't see how you can guarantee it, because the retro system gets turned on, right? 5 volts gets applied to one ROM. You might have a chip select line that's automatically being pulled high by the hardware. Right. So 5 volts immediately goes to that GPIO. It's also going at the same time to the voltage regulator on one ROM, but that's going to take a little bit of time, a few nanoseconds, to start generating the 3.3 volts. So there's a window condition where you can potentially fry the GPIO on the RP2350. And I don't see how you can add protection circuitry for that. I've basically got 1/2 inch by 1 inch for all of the components on this PCB, which is not a great deal. So the other problem with the 2350 is 5 volt tolerance is it's only a maximum absolute voltage of 5.5 volts, which is mostly fine. But I've had voltage regulators go to 5.5, 5.6 volts on these systems. So on the other hand, the RP2350 is a much more powerful microcontroller. Right, it's got dual core, it's got PIOs, it's got more flash associated with it. So you can do some much cooler things on one ROM with the RP2350 version than you can do with the STM version, because you've got all this extra horsepower, and you don't just serve bytes, you can run software stacks in the background and turn your one ROM into more than a ROM and add some pretty cool features.
Yeah, I mean, it is important for people to realize the size that we're talking about, right? Electronics have shrunk, over the ages, but we really are talking the size a little bit bigger than your probably about the same size as your thumb, from the knuckle to the end of your thumb. Right?
Do you guys have one? Either one of the one ROMs or a chip to replace?
So that's a one ROM.
Ah, gotcha.
So, and that's my thumb.
Pretty small indeed.
So yeah, I was pretty spot on there. Yeah, little smaller, depending on how fat your piggies are. I've got fat fingers, so it's a little bit smaller than mine. Yeah. But yeah, so I mean, it's just important. I just want to make sure people understand what we're talking about. We're talking about designing essentially a whole system using a microcontroller and all the logic and everything you need to run this thing, including the voltages, the logic levels, all of that. Onto that size, right, is very, very difficult, and you run out of room really, really quickly. So, if correct me if I'm wrong, Piers, I'm going to step out and take a risk in my knowledge. But we were talking about the 5 volt versus 3.3 volt. If you were going to have to shift the logic level from 5 volt down to 3.3 volt, right, on all of those lines that you need to communicate on.
Yep.
Each one of those would require at least a transistor and two resistors, I think, to do the level shifting.
So you can buy a package that actually level shifts 8 lines
8
for
at a time.
you. So you need 3 of those packages, and they would physically fit on the underside of one ROM if you bunched them right up against each other. But you would at least need a 6-layer PCB, which is quite expensive to have manufactured. But you may not be able to, even then, you might not be able to do it in the footprint that you've got, because you've got vias going through the board and they go in the way. It becomes an extremely difficult challenge to use external level shifters with this sort of footprint. It's just so small.
Yeah. And I saw the video that you published recently. I guess YouTube knows that I'm interested in this stuff. It came up like the day you released it on my feed. We should mention you're adding USB programmability to these things to make them easier to program. But even that, you've got to fit, even though it's small, right? We're talking about like micro USB size connections, right? To plug in a USB cable. But even that, you've got to shift everything around. I remember you saying in your video, maybe if I shift this up by 0.5 millimeter here and move this 0.5 millimeter over, then I can fit the connector out. I'm like, man, these tolerances are tough.
Yeah, I mean, you're in for a treat this week then, because this week's video, which went live 2 hours ago, is 2 hours of me relaying out the RP2350 board adding USB.
I was wondering about that.
It took me 8 hours to relay it out. Wow. I had to start from scratch, delete every single track on the board, and I was crying when I was doing it. But yeah, again, you can see me I'm literally just moving things around 1/4 millimeter at a time just to make everything fit. And people sort of say, well, can you put USB-C on there instead of micro USB? And it's like, I would love to. But you actually don't know that a USB-C adapter takes up maybe 10 to 14 square millimeters more on a board than a micro USB. I'm not sure it can be done.
Yeah. All right, I want to ask another sort of dumb background question before I get into the more like modern technical questions. These ROMs on these legacy computers, what do they do? Is this just like, again, coming from my background, is this just the BIOS that helps you get booted up, or what all lives inside of the ROM?
Yeah, well, kind of. So on a Commodore 64, I'll use that as an example. It's the one I'm most familiar with. You've got a kernel ROM, a basic ROM, and a character ROM. Think about the kernel as essentially being the low-level operating system of the C64. That actually allows the processor to run and does some useful housekeeping stuff, like checks whether the keys have been pressed on the keyboard, that sort of thing. You also have the basic ROM, so that's got a basic interpreter running within it. So on these retro systems, you get booted up, you tend to get presented with a basic prompt, and then you can write 10 print hello world, 20 go to 10, and then you can type run and it runs the program. That's the basic ROM. You then got a character ROM, which contains essentially a mapping between the characters that the program or the CPU has requested be placed on screen to the bits that the video chip actually, the pixels that the video chip actually needs to mark in whatever color is set on the screen. So they're absolutely crucial for running of the system. Although, as I found, on a Commodore 64, you need to have the kernel or it simply won't run. You need basic when it boots, but if you don't run a basic program, you can rip the ROM out later because it's not accessing basic at that point. And the character ROM is only really required if you want to read stuff on the screen, which is probably most people. But for me, doing a lot of debugging and testing of these systems, I found that you can do an awful lot of bad things to the character ROM and the system will keep running.
Yeah.
So I don't think it's actually that much different for people who may be used to doing, programming like, ESP32 or an Arduino. It is different in that, in these old systems, a lot of these things were separated out, whereas now they're embedded, right, all together. But, you write a program in, let's say, Arduino, right, and you upload that to your ESP32 or Arduino board. And what you're essentially doing is, at that point, you're programming the ROM for the system. Because what the Arduino is going to do when it boots, it knows to go look for that programming if it's there and run it, right? Same thing with these older systems. The processor, in this case, the 6502 processor, which was so ubiquitous, knows, hey, when I've got power applied, I want to go out. The first thing I want to do, well, it does some other things, but basically when I'm ready to run things, I'm going to go out to this address and run whatever lives there. And what lives there is on one of these ROM chips. So it is quite similar to if you think of it from, if you're a maker and you've programmed these things before to run your LEDs or whatever. I know I'm simplifying it. It's not too different from the way these old systems work.
Yeah, and that goes back to what I was saying earlier. I totally agree with you. It's if you sort of get involved with these old systems where things are relatively easy to understand, you can then take that forward and understand, I think, better what's happening on the modern solutions, because it is fundamentally the same thing. The processor on an old system or a new system boots up and it looks at some memory address to get its first instruction, and then it starts executing instructions from there. It's just, does it live on a ROM chip or does it live in flash that you've programmed, right?
Yeah. Speaking of programming, you're looking at putting a USB connection on these. What does that process look like for someone to say, I want to put a different ROM on this?
Yeah, I've spent about the last week on actually building the tooling around this, and I'm taking a web USB and actually WebAssembly approach to allowing these systems to be programmed via USB. So think about your ROM chip. It's got a micro USB connector on it now. You jack it straight into your PC. It can be Windows PC, Mac, or Linux. Then you can point your browser at onerom.org and select the ROM that you want to program, press program, and hey presto, you've got a new firmware and a new set of ROM images programmed on your One ROM. And the technology that allows this web USB and WebAssembly has been pretty fun to understand, and I think it's a really interesting way of, it's really simplified embedded device flashing web USB for systems that support it, and there are some incompatibilities with some browsers, WebAssembly is also, I think, a really interesting technology. I wasn't familiar with it before I started playing around with it for One ROM, but it allows me to take the generic tooling that I've built for One ROM that I've actually written in Rust and compile it and run that Rust code directly within my browser. And that's how I'm parsing and generating new firmware images directly within the user's browser before it gets flashed to the device.
Yeah, that's super interesting. I'm going to ask a really nerdy question. Are you using like little FS to actually store the end goal firmware file that you want to host?
No. So I'm doing a lot of processing of the ROM image actually before it gets stored on the device. That's kind of the first thing to say. Mm-hmm. So to make the PCB itself routable, I have to have what looks like a fairly arbitrary or random mapping of the GPIOs on the device itself to the GPIOs to the pins that actually are going into the ROM socket. That means I need to, because I don't have any spare CPU cycles on One ROM itself to be manipulating things and still hit the speed requirements for these ROMs, because we're talking about very small numbers of hundreds of nanoseconds that you have to play with. I have to do all the pre-processing of the ROM images before I store them to the device. And then I'm just storing them as chunky, they tend to be either 16 kilobyte or 64 kilobyte images that then get stored into Flash. And I'm literally just storing them at locations in Flash, and then I have a pointer table to those. I'm not using a particular file system to do that. And there could be problems down the line with wear leveling, but I'm not really expecting people to be writing their ROMs tens of thousands of times. For most people, it will be they program it once, right? Their kernel breaks on their Commodore 64. They buy a One ROM, they program it with the web browser, and then it sits in the machine and hopefully works for another 40 years.
Yeah. These are read-only memory, after all. So the right wearing shouldn't be a problem.
Are you playing with Wi-Fi or Bluetooth at all with these?
Yeah, so I of course. So I couldn't really fit Wi-Fi on One ROM itself. And so for that reason, and also for the 5-volt tolerance reason, I decided not to go down the ESP32 path actually on board One ROM. I also felt actually it might turn people off One ROM if it had Wi-Fi built in it natively. I don't want to have Wi-Fi in my retro computer. And
sure.
That's fine.
Sure.
So what I did is I built a tiny little adapter board that could be plugged onto the back of One ROM, which I'm calling AirFrog, which uses an ESP32C3 Mini, which is a tiny little module with the antenna built in. And that then uses, we're going to get super nerdy now, it uses SWD, serial wire debug, which is an ARM debug protocol supported by basically every ARM Cortex-M processor out there, of which the STM32 and Raspberry Pi RP2350 are. And AirFrog can then go in and manipulate the flash, the RAM, and the hardware peripherals on One ROM without One ROM's microcontroller having to do any work or even being aware that that's happening. So that's my approach to Wi-Fi. And then you can use AirFrog, right, to dynamically reprogram One ROM. You can even reprogram the flash of One ROM, so the firmware and the images that it's going to serve, under the feet of the microcontroller without affecting its current operation. Only when you reset the system does it then reload that back from flash.
Oh, nice.
And be running the new. Serial wire debug, actually, I couldn't believe the sorts of control and capabilities it gives you over the microcontroller until I really dug into it. But I think it's actually a hugely interesting area that people can exploit to get some really interesting functionality out of a kind of. I think of AirFrog as a coprocessor, actually, because you can offload functionality from your main ARM MCU to this ESP32 module. It doesn't just have to be a sort of Wi-Fi antenna sending data out and receiving data back in, but you could actually offload specific elements of programming to the ESP32 over this SWD interface.
Yeah.
And will that work? Will AirFrog work with both the STM version and the RP version?
So, yes. It doesn't work with the USB version because I don't expose the serial wire debug as a programming header on the USB version because I don't have the real estate. But Airfrog today works with the STM32 version. That's because the Raspberry Pi designers used a more advanced version of SWD on their chips, which I don't yet support in Airfrog. But it's totally doable and possible to add the same capability for the Raspberry Pi on Airfrog.
I'm looking at onerom.org, the built-in programmer, and you've got quite a few different images here that can be served. I'm curious how that works with copyright. Are we just sort of in the gray area here in serving these binaries?
I think we're in the gray area here.
Okay.
I mean, the ROM images that I've pre-built and allowed to be served on onerom.org have been available on other websites for decades. Anything that's modern, that's maybe a new diagnostics ROM for one of these systems that has a proprietary license associated with it, I'm not building and putting up on onerom.org, right? Because I don't want to get involved in those licensing questions.
Right.
But where there are new diagnostics ROMs that are open source and the licenses are amenable, then I pre-generate those. And I'm not actually hosting that stuff myself. GitHub's hosting it on my behalf. But yeah, we're slightly in the gray area here.
So that was actually going to be my follow-up. Like, how much of a community effort is there building new ROMs, new images for some of this old hardware? Is this a thing that's being done?
Yeah, it's being actively done. So people are still generating new diagnostics ROMs for some of these systems. I think whenever a new diagnostics ROM comes out, it sort of moves us forward a little bit and gives you a way of diagnosing some problems that couldn't have been diagnosed before. But I think there's always going to be some extra latitude there for someone to come up with a new version or a new capability or a new feature that wasn't conceived before. I mean, I'll give you a fairly basic example. One of these disk drives sitting behind me is a Commodore DOS1 disk drive, right? And they're actually different in lots of different ways from the Commodore DOS2 disk drives. And the Commodore 2 disk drives have quite a lot of diagnostics built into them. So you boot them up. If there's something wrong, it does a flash code on the disk drive to kind of tell you what's wrong. The DOS1 disk drives don't have that. So I built a diagnostics ROM for the DOS1 disk drives. And that's actually one of the things that got me into this. I found myself constantly reflashing a ROM, taking the EEPROM out, sticking it in a UV box, waiting 2 minutes, smelling the ozone coming out of the UV box, putting it in my $50 programmer, programming a new version and finding I'd made an error and it wouldn't boot and going through the whole rigmarole again.
Yeah, that's quite the barrier to entry for someone new. Like I've found that when your instructions start with pull out your JTAG debugger, you lose 99% of your potential audience.
Yeah. I mean, I think USB is absolutely critical for any kind of mass adoption of this sort of technology because it's so ubiquitous, and making it just as simple as you possibly can. No downloads, no drivers, no native applications. If you can do everything from within in a web browser, which some of these new technologies allow you to do, I think that's huge.
Yeah, absolutely. Are people going nuts with building their custom firmware? So like a lot of these machines are built on BASIC, and so I suddenly have this crazy idea that could you replace that BASIC interface with a Python or a JavaScript? Are there people out there working on that?
I don't know about those examples specifically. Aaron, have you heard of people doing that?
I think that you're going to be pressed for space. If you go out, I think Microsoft just released the code, right, for their BASIC interpreter version 2 or something like that. I mean, this is going back to the early days of Commodore and other systems that ran this, right? So you can actually see the code, you can see the comments, but I think all of it was like, I don't know how many lines, like 10,000 lines or something. I mean, something very, very small, right? Because they had to write it. The reason it was so small was because they only had these small ROMs to work with. So they had to conform to the constraints of how much memory am I going to have, how much ROM space am I going to have to put my interpreter, my BASIC interpreter on, right? And so I think that's going to be the issue is if you wanted to do something more modern like Python or JavaScript or Java, I guess, or JavaScript. I think the interpreter itself would be beyond the constraints of what the system's able, the amount of memory that the system's able to address. But I could be speaking out of my butt at this point.
I mean, that actually takes me to a potential future for One ROM, and this is pretty out there. But I have been thinking along the lines of an almost infinitely scalable ROM implemented with One ROM, because it's software.
This is the direction I was going. Yes.
Right. Yeah. The ROM that it's serving doesn't have to be static. It could be streamed in via Wi-Fi, or it could have a much larger ROM stored on its flash or in its RAM that it's continually updating the main ROM image with, and then you could potentially implement much larger capabilities. Python interpreter, I hadn't thought of that one, but maybe viable. I think this is a bit of a challenge to achieve.
Oh yeah, of course.
But there's another approach that is being taken in some of these areas that I wanted to call out. And so one example is the Meatloaf project for the Commodore 64, which is a peripheral emulator for the Commodore 64. So it essentially looks like a disk drive and other peripherals to the Commodore 64. But it's all built around an ESP32 module. So it gives Wi-Fi access to the Commodore 64. So you can retrieve files. You can just type load on your Commodore 64 and pull down a file from the internet and run that on your Commodore 64. But one of the things that they've added is the ability to offload more complicated function onto Meatloaf to enable your Commodore 64 to have access to these capabilities, but without needing the CPU and the ROMs to do it. So one example is to retrieve a web page and then do the JSON parsing of whatever that web resource returned. That's offloaded onto the Meatloaf device, but the results are made available to the Commodore 64. So you can get much more advanced programs on the retro system by using one of these peripherals.
So there you go. Mashed Potatoes, one of our listeners, and he commented that it would be difficult to find the AI angle this week. There you go. The Meatloaf lets you run AI queries on the Commodore 64.
Absolutely, it does. I mean, actually, one of the common demos of it's not AI, but is Chuck Norris jokes downloaded randomly from the internet. So you type run, you get a new Chuck Norris joke.
Yeah, of course. Let's see. Are you basically just bit banging? There's no accelerated support for this, right? You're basically just bit banging GPIOs.
Yeah, basically. There's quite a lot of work has gone into the main serving loop to optimize it down to operate in the sorts of tens or very low numbers of hundreds of nanoseconds that are required here. But fundamentally what's happening is reading a GPIO port that's giving you the address and chip select line state, looking up a byte from RAM, and then applying that to data lines. So actually writing the value that you read back from RAM to the data lines, and then also turning the data lines into output. And then when chip select goes inactive, making it inactive again. So yeah, it is fundamentally just a bit banging approach.
Yeah. Fun.
Can you now we're kind of talking about futures and things as well. I'm just kind of curious what your plans are for the future, and I'll kick off with I'm kind of curious. I mean, ROM switchers have been around since these things were new, right? Back in the day, people would make ROM switchers. They'd put a bigger ROM in the system and then divide it up into different address, 4 different address spaces or whatever. They'd load smaller ROMs into those address spaces, and then they'd flip a switch and say, on the Commodore case, now I'm running Jiffy DOS, right? So when I boot up, instead of running the regular basic, now I'm running Jiffy DOS, which speeds up my disk interactions and all that. Is that capable now, or have you thought about making that doable in the future?
Yeah, One ROM is capable of that and more today. So it can operate, number one, in a very basic. It can have multiple ROM images stored simultaneously, but you have a bunch of header pins, and you apply jumpers to those depending on which image you want it to load when the system boots. So that's the first one. The second capability is what I call dynamic bank switching, which allows you to on the fly switch between up to 4 different ROM images. And I have quite a nice demo of switching the character ROM on the Commodore 64 as it is running between, a Star Wars and a Tolkien and a standard C64 character set to demonstrate that bank switching.
So literally, as you're typing, you're switching the character sets. You're typing the same keys, and then different characters are coming up.
Actually,
cool.
what I've got is I've got a basic program running, and it's streaming text, and then I move the jumpers around, and the whole screen just changes, and you get a glitch on the screen of one video frame,
sure,
recording via the camera, but it just switches like that. And then the third capability is what I call multi-ROM sets. So a single one ROM can actually emulate up to 3 ROM chips simultaneously. So you don't need your kernel, your basic, and your character ROM in a C64. You just put one ROM in one of the sockets, and you run a flying lead from the chip select line of each of the other 2 sockets into one ROM, and it can replace all 3 ROMs with that single
That's cool
solution. Yeah, makes sense. So we mentioned a couple times here sort of the 386, 486 generation of machines, and currently that's beyond what you're doing. But in thinking about what I've done with these, there's a component in some of these machines that is infamous for dying, and I believe they are starting to get hard to source as well. And that's the Dallas real-time clock. And those bless whoever's heart designed it this way. They have the battery built into the chip, and so it's not replaceable. And on most of the machines that I've worked with, when that battery dies, the machine fails to boot altogether. You can't bring it up. So is there a future where you can replace your old Dallas RTC with a One ROM and get a 386 machine going again?
I don't know enough about the RTC chip to know the answer to that. I know there are modern solutions to that problem. I know a YouTuber called Necroware has come up with a solution for exactly that problem, although I'm not going to talk technically to it. One thing I am looking to branch out into actually is the PLA on the C64. So the PLA is another very crucial component within the C64 that often fails on these systems. And I may be able to take a similar approach to One ROM to replace the PLA, although there's quite a lot of solutions out there for the PLA, so it may not be worth doing. I would like to go to larger ROM chips though. I have a prototype for a 28-pin ROM lying around this workshop somewhere that I need to solder up and test, because to go above the 8 kilobyte ROM that I'm currently supporting, you need to go to a 28-pin ROM. And those were used in some of the later C64s and some of the later disk drives. And then you get into sort of Amiga territory. You need to be able to support these larger ROMs. So I'm going to see if I can also go up into the 28-pin ROM space. But no, PCs, 386s and 486s are not my target market right now.
Is that just beyond what you're looking to do with the One ROM?
It is beyond what I'm looking to do. What I don't know is I don't know just how fast One ROM can go. So the ROMs in these Commodore systems, they tend to give you about 200 nanoseconds from the chip select line getting asserted, so the CPU saying it wants a byte, to you having to get the data applied to those output pins. Right, 200 nanoseconds. It kind of sounds like a lot, but that's 20 cycles at 100 megahertz, which is a reasonable clock speed for some of these microcontrollers. Yeah. But you can overclock these microcontrollers fairly reasonably and safely, I've found. I'd like to see if I can get down to sub 100 nanosecond access times that were, again, the later machines, the more advanced machines, not only do they need larger ROMs, the ROMs provide better, faster access times. And the 100 nanosecond mark, I think, is doable with the One ROM architecture. But I'll be honest, I don't know enough about the ROMs that are in systems like the 386 and 486 to know, A, whether this approach would scale to those, and actually, B, whether there's as big a problem replacing them as there is with the older machines.
Right.
Yeah, that's what I was going to ask. Not necessarily the 386, 486, but the IBM PC, the original IBM PC, for example, or the XT or the AT, 286 era, I think may be doable. What other systems have people been clamoring for beyond, Commodore 64? And by the way, I know there's the TI-99, right?
Yep.
And even a Coco 2. So Coco was my first computer, so I loved seeing that. But what other systems, do you think this would be possible to use in?
So definitely the Atari line of computers, and that's my next personal target, is to start building up my Atari collection and seeing what systems I can replace ROMs in there. And then actually I'm probably most interested in some of the non-computer systems like the keyboards and the pinball machines, and seeing if One ROM can actually just be a general solution for everything that ever used a 2300. It's interesting you asking the question about what other systems are people clamoring to support. What I actually hear, I don't think I would hear a lot if they tried a One ROM in a new system and it just worked. You only ever hear about the problems.
Right.
But yeah, the other types of systems would be very interesting to try, pinball machines and keyboards and so on.
Yeah. We talked a lot about the kind of the technical details of the project, but not about the open source nature of it. And so let's dive into that in the time that we have left. And so, I'm curious, what license is this under, and then what level of community support and engagement have you gotten so far?
Yeah. So the licenses that I've chosen here are MIT for all the software, all the firmware, so very permissive license, and CC BY SA 4.0, I think, so share alike, but I haven't put any commercial restrictions on the license for the hardware, and I would actively encourage anybody who wants to get their own One ROMs fabbed and assembled and wants to sell them commercially, please do so. I'm not looking to make money out of this project. I'm not trying to keep control over this project. I want to get One ROM. I'm trying to solve a problem fundamentally. You asked about community engagement. So limited so far, and I think that's to be expected for a fairly new project from an unknown person. But I've got some fairly good engagement from some of the some quite popular YouTubers, and also quite developers with other open source projects have been helping me out with One ROM, and I've got a few contributions and a few discussions going on GitHub. But I really want to hear more from people who've had their own One ROMs made, might have had some successes or failures, to share those with me, and I can make One ROM better if people do that. I've also just started selling a few One ROMs myself on my own online store, really because I have some spare, because I get so many fabbed by JLC, and I want other people to share the One ROM fun. But as I say, I'm not looking to actually make money. I'm selling those at close to cost. But I've only done that in the last week or so. So actually, I'm expecting over the coming weeks, the coming months, more people to get One ROMs and actually start to say, I hit a problem here, can you fix it? Or I would like to submit this pull request to the project because I've had this great idea of making One ROM better. So really looking forward to more community engagement moving forward.
I was just going to say, I know you mentioned earlier you went to some conferences and things. I mean, what's the reaction been so far from people that have used it?
Yeah, it's been overwhelmingly positive. So I went to VCF Midwest in Chicago last month. So that's Vintage Computer Festival. I think the Chicago one is actually the biggest vintage computer festival maybe in the world. And it was huge. And I met some really great engineers and really great hobbyists there, and everyone was really quite excited about One ROMs. And that's actually why I have some spare One ROMs to sell. I managed to smuggle about 50 into the US without paying tariffs on them, and hand them out to attendees at VCF Midwest. And I only came back with about a dozen that I then sold.
Yeah. God, my mind entirely went blank. I was off looking at VCF. I'm fairly close to Dallas. I'm not going to Chicago, but VCF Dallas maybe would be something I could get to.
It's a great intro.
Go. Yeah. One thing is the community is so welcoming and nice. That the thing that I think would surprise me if I were to put myself in a newbie's shoes, is you go and you just geek out with people about stuff. People love talking about their projects and about these computers, and there's no animosity, there's no you don't fit here in this community, and none of that stuff. You just go and talk to people and have a great time and learn about stuff that maybe you didn't know about. That's what I love doing. So you should definitely go. You would love it.
Yeah, it'd be fun. I remember now, I was going to ask you, Piers, it seems like this is probably niche enough that you don't have to worry about clones showing up on Alibaba.
I would love clones to show up actually on Alibaba, AliExpress. That's actually I have a vision for an end game. I would love Chinese manufacturers to be ripping One ROM off, or thinking they're ripping One ROM off, and actually selling it, because it proves there's a market for it, right? It proves I've created something of value that is actually useful to people,
right.
and they want.
Yeah. I'm very intrigued by the idea that it will have a life beyond just retro computing, right? Because I hear stories from people sometimes talk about, this piece of industrial equipment that they have that's been there for 40 years that runs on a Commodore 64. I think it would be hilarious and quite fun if it turns out that the biggest market for this is something that nobody has ever heard of. But there's 10,000 of these Commodore 64 based CNC machines that you get a huge order for, and I think that would be a lot of fun.
I actually think maybe AirFrog actually has more legs in that direction than One ROM, because just imagine how many industrial embedded systems based on Artex, Cortex-Ms there are out there, and being able to piggyback on top of that with a coprocessor that would allow you to offload processing from the main core or do firmware upgrades remotely where you can't physically get to, it involves a truck roll to go and actually do a firmware upgrade normally. I wonder if that actually has more legs. But no, I'd absolutely love to hear about the most wild and wacky places people have found use for a One ROM.
Yeah. It's kind of the reverse, maybe, of what happened with the Gotek, right? So, for those that don't know, the Gotek is a floppy drive, 3.5-inch floppy drive replacement. It was initially, I believe, meant for industrial applications, where they had these old machines and the floppy drives would break, and they needed a modern replacement. So Gotek, you have a USB port on it, and you put your floppy drive images on there, and you can run your old equipment. Well, then the community found, and they're only about $20. And so the community found out about them, and the community, one of the most common things for people to do for 386s, 486s, but older machines that had floppies as well, is to replace the old floppy drive, the 3.5-inch, with a Gotek. And, especially for things like Amigas and Atari STs, those can be hard to find, but throw a Gotek in there, all your images are right there. You hit a button, you can cycle through all your floppy images and go to town. So it's kind of the reverse of what happened with Gotek, maybe. We'll see.
Yep.
Yeah. How about some of the different projects that are sort of rebuilding the Commodore 64 or making new 6502-based hobby computers? Is there some synergy between those and this project?
So I don't know whether the project actually launch a new version of the Commodore 64 is going to use these 8 kilobyte and 4 kilobyte ROM chips, or they use a more modern solution. But I would expect whatever solution they're using, they're probably not going to need to put a One ROM in it, because they'll have something that should last at least 10, 20 years, if not another 40 years. But yeah, I've actually got a buddy of mine who's been actually building his own computer from scratch using a 6502 and a bunch of logic chips, and he came up with some cobbled together solution for a ROM for his 6502 to run. And I kept saying to him, dude, look, just let me send you a One ROM. It'll be so much easier. You won't have to use this cobbled together solution. Fundamentally, it is quite a simple thing that's being done here. That you're just looking for address lines, you're looking up a byte in RAM, and then you're putting it out on the data pins. So there's a huge, that's why there's actually so many different applications for this, and so many different sorts of equipment, computers, keyboards, pinball machines, and I'm sure the list is actually really quite long that used these ROMs back in the day and could use replacements, at some point.
Yeah, I was thinking of Perifractic and the Commodore buyout, but also like the Commander X16. From the 8-bit guy is another one that comes to mind.
I'm pretty sure that the Commander X16 is using a much larger ROM than one that One ROM tries to emulate.
Yeah, very possibly. The interesting thing about that one is it's actually built on the 6502, whereas the Commodore relaunch, I'm pretty sure they're using an FPGA to sort of re-implement it.
Yep.
Either way, it's super fascinating to see these projects come together.
Yeah.
So what we talked a little bit about this. I'm curious if there's another story you have. Is there some place that someone has used the One ROM that's really surprised you? That's been really odd? No,
not that I've heard so far. The first story I had actually coming in from a user that said he'd had his own One ROMs fabbed, and it was astonishing to me. This was really early in the project that anyone had actually done that, and he'd put it in his VIC-20, and being in the US, he had an NTSC video standard VIC-20, and I've only tested on PAL gear because I'm over here in the UK, and it didn't work. And I thought, well, it should work. Let me have a think about what's going wrong. And
those silly
it turned
Americans.
No, believe me, my immediate thought is I've done something stupid. And I looked into it, and he'd actually used a slightly different STM32 microcontroller than the one I'd expected, and it was much lower in flash capacity than I'd thought that chip had. I'd said it would work, but I didn't realize just how small the flash. Well, actually, no, the RAM.
Some of those only have 20K of RAM.
It had like 72K of RAM, I think, that particular chip, and the way I'd written the code didn't quite fully support that. So, an hour later, I had a firmware build that had that limitation lifted, and I emailed it over to him, and he was like, I just can't believe it. It's actually working. I had these things fabbed on JLC. I got in touch with you. I got a firmware back that works. This means I can now finally close my VIC-20 case, because the other solution I had was too large, right? It was one of these EEPROM-based solutions, and he couldn't physically get the cover back on his VIC-20.
Right. Oh, that's great. Yeah, I've done a little bit of work trying to support a device that only had the 20K of RAM with one of those STM32 chips, and that is not a fun time. See how much fat you can trim off of whatever image you've got to make something work.
I did actually start with the very low-end STM32s, the F1 series, the ones that are used in the quite popular Blue Pill boards. I think some of those only have 20 kilobytes of RAM.
Yep.
But actually, it turned out those don't have all 5-volt tolerant GPIOs. And that turned out to be a problem for One ROM. So I had to step up to the F4, which is used on the Black Pill board. And those have 72 kilobytes upwards.
So you've got the STM32 and you've got the RP2350 version.
Yep.
Is there another sort of hardware revision in the works? Or
right now, it seems there's always hardware revisions in the works. So let me just give you the lowdown on that. So I call the STM32 version, I call that ICE, and I call the RP2350 version Fire. Now, I'm just going through a rebranding exercise. And I chose those names because the STM32's logo is blue, ICE, and Raspberry Pi's logo is red, Fire. And actually, I think the RP2350 version will be more powerful because it's got the dual core, it's got the PIOs, and so on. And then also moving towards a future where I have kind of like a Pro version and a USB version for each of Fire and ICE. So the Pro version has the SWD that allows you to plug the SWD programmer in. You can put AirFrog on it. You can do some really quite advanced and funky and cool things. And the USB version is for the person who just wants a ROM to work in their system. The Pro version, the SWD version, is pretty static at this point. I'm pretty happy with that. I've been using it for months with no problems. A bunch of other people have been using it, have had their own boards fabbed. USB is very new. I've had that working for about a week and a half with the ICE version, the STM32 version, and I literally sent the Fire version, the RP2350 version, to fab on Friday last week. So yeah, Pro SWD is fairly static at this point. USB will continue to move for probably the next few weeks, next month, would be my guess.
You have an obvious opportunity here to also make an Earth and an Air.
It has been in my mind, but I don't know what they would actually be, and I want to kind of avoid model proliferation if I can. On the ICE version, I already support like 10 different variants of STM32, and that's good for techies. Right? It's good for engineers who want to optimize everything and choose the thing that's absolutely right for them. But it's not great for the average user. He says, "Look, I just want a ROM replacement. Just right. Paradox of choice, right? Don't give me so much choice. Just give me the thing that I need." So yeah,
that's what I was going to ask, because once you start multiplying those different versions out between, it's just like it's a nightmare, right? There's a bug I've got to fix, and it's just So at some point, is there a direction you're leaning at this point? Between STM and Raspberry Pi for the future, or do you think you'll continue down this dual path for a while?
I think I'm going to continue down the dual path.
Okay.
And the reason for that is because I'm still a bit worried about the RP2350's 5-volt tolerance. And look, I'm not having a go at the RP2350 here. It's very clear in the data sheet what you can and can't do with it, and I'm not quite following the data sheet in some circumstances. But I think time will tell how robust the RP2350 ends up being in this application. If I wanted to do something really cool and sexy and advanced with One ROM, I'd be going the Fire route, right? I'd be going the RP2350 route because it's got dual core, it's got the PIOs, it's got lots of horsepower in there. If I wanted a One ROM that was just going to sit in my Commodore 64 and work for the next 40 years, right now I'd be using ICE, I'd be using the STM32.
Yeah, makes sense. All right, I've got to ask a couple of final questions before we let you go, and that is, what is your favorite scripting language and text editor? And I suppose retro answers are acceptable.
Text editor, I still remember Slick from the mid-90s, Visual Slick, that I used when I first got a software engineering job. But these days I use Visual Studio Code for all of my editing needs. Scripting language, I would have said Python a few years ago, and this is going to be, I think, a bit of a weird answer, but I'd say Rust today. And I know Rust is not a scripting language, but I today use Rust for the things that I used to use Python for tooling and for quick scripting type applications, because and there's a dirty little secret to share here, which is that using AI, and I use a lot of AI to help me with my coding, right? It's so much easier to write Rust that compiles quickly rather than when you write Rust yourself, getting the damn thing to compile within, it can take days to get the thing to compile. It's super quick now to write stuff in Rust. And it is kind of true what people say about Rust, that once you get it to compile, it's pretty likely to work. Whereas with Python, you can write the most, awful scripting code, and then you run the thing and you're constantly trying to whack the runtime bugs that you let through. So that's on my channel. One of the things I'm actually continuing to try and showcase is using Rust for development and how easy it is, not just for scripting and tooling on PCs, but also for embedded development, because it has a huge number of benefits in things being much more likely to work and be more maintainable for the future over, some of the more traditional choices like Python. So that's probably set up a flame war in the comments. Well,
that's fine. That's an interesting answer, though. I don't think I've ever thought about that. The compile time strictness of Rust makes it suitable for vibe coding, if we want to use that term. That's actually,
is it similar? Would you say, because I'm not a Rust person, I'm just kind of curious, would it be similar to the way I think of writing C++, or a lot of different compiled languages? But like when I run, when I'm doing Arduino, coding for Arduino or ESP32, and I'm using the IDE for that, then it does compile it ahead of time. And oftentimes, as long as it does, compile correctly, and you get to that point where it moves on to actually uploading the binary to the device, you're like, whew, okay, as long as I got, the right GPIOs and everything, it's probably going to work right at that point. Yep. Would you say it's similar to that concept?
It's a reasonable analogy. I've just had too many cases over my history, both in professional and, hobbyist software development, where I've written something in Python and it's flaky, and I never care about it enough to go through and make it really robust. With the advent of AI helping me, I can get to a position where I have something working in Rust much more quickly, and it tends to be far more robust for the long term as a result of that. So all of the tooling that's built around One ROM, and there is quite a lot of it to make sure that the ROM images get packaged up in the right way and the firmware gets built correctly. I might historically have written that in Python because it's not part of the core code. I've written it all in Rust now, and that's been, I think, a really, really good solution.
Yeah.
Interesting.
Your C++ analogy, what comes to mind there is that it's so easy, even in modern C++, to dereference an old pointer or double freeze something or forget to freeze something and you have a memory leak. And most of those things Rust just won't let you do. The compiler will just say, nope, you have to do this better. Try again.
Unless you really want to. And Rust does very grudgingly allow you to write unsafe code and dereference pointers directly, and that can be quite fun when doing embedded development to take all the guardrails off. Yep.
All right. We are past time. which that's fine. It's been a great conversation. Piers, thank you so much for being here. It was very fun to hear about the project, about One ROM, and where it's going and where it's been. Thank you for your time.
Yeah, it's been a great time for me as well. So thanks for having me.
Yeah.
Yep. And I'll reach out, Piers, after the call's over.
Brilliant. Look forward to it.
Very good.
All right.
All right. What do you think? You gonna run out and buy one for your own systems?
Of course, I was, ready to build one up already when you reached out and said, "Hey, we've got this show coming up. Do you want to do it?"
Yeah.
I'm like, "Yes." I've got the webpage open. I didn't have to, reopen it. Usually, when we do these things, we do maybe a little bit of research, not much, but a little bit of research. And no, it was already open in a tab in front of me, so I didn't have to open any new tabs to do this, and I'd already looked into it. So no, I'm super excited about it. It solves an important problem for the retro community, and it opens up more possibilities for other things, as Piers was mentioning. It's pretty neat to be able to plug one chip in and replace a whole row of chips, the functionality, right, just with one. Granted, you have to run a few jumper wires to connect the chip select, but I'm really excited about it. I would also say for people that we talked a bit about 6502 and how chip select works and things like that, I would recommend to folks if they want to learn the basics of how these things work, and you have a little bit of knowledge of maybe doing some breadboard work, building circuits and things like that, to go check out a channel from a guy named Ben Eater on YouTube. And he has a whole series that he's been doing about building a 6502 based computer on a breadboard.
Oh, nice.
And some of those early videos he did were excellent in explaining how it works, how the chip select stuff works, why you need a ROM. And basically he just stitches it all up on a breadboard with jumper wires and gets it to work. And he goes through why it works and how it works. It's very fascinating to me.
Yeah. That kind of ties into the thing that I think is the most interesting about the One ROM, and also the companion chip to it, the Airfrog, I think you called it. I think it's going to enable people to do more custom ROMs. It's going to make it easier because he talked about the old way that you flash one of these ROMs, right? You put it in a UV box for a couple of minutes, and then you go and you put it in your programmer, and then you go and load it back in the machine. The ability, and this is what I find in programming. The tighter I can make my loops, I write code, I compile code, I test code. If it takes you 30 minutes to compile code and test code, well, you're not going to make much progress. But when you can get that down to, a 30-second loop, or ideally even faster, then you can get through bugs, you can try things, you can do it so much faster, you can make so much more progress. And I think it's going to be interesting to watch as more and more people get these, and particularly the ones that are so much easier to flash and play with. You might see a resurgence of like custom ROMs. Think people doing new things on these old systems, and that's pretty cool to think about and pretty exciting to look forward to in the future.
Yeah, and now, as much as we all hate to admit it, with the advent of AI,
sure,
it's getting easier for people to have an idea and then do the programming. But like you say, if the barrier to entry is, I don't have a programmer to actually get the software on the ROM to test it out, that's going to become the limiting factor, where I think previously the limiting factor was, do I know enough to write the code to make the thing work that I want to do? Now with AI, you can do that.
Yeah.
So you need to have the processes in place and the equipment in place. And in this case, it's removing a pretty big barrier, I think, for people that aren't familiar with this old technology.
Yeah, absolutely. Absolutely. All right, Aaron, is there anything that you want to plug before we let folks go?
Well, of course, YouTube channel is the thing that I'm doing these days. So go check out Retro Hack Shack on YouTube and Retro Hack Shack After Hours. Nothing nefarious going on after hours. It's just an extra channel for me to post all the stuff that's, I know it probably isn't going to perform well on the main channel. And it's like personal projects and things like that. So go check out both of those and subscribe to them. I've been releasing a little less frequently lately, but hopefully that'll change here coming up in the future. But yeah, lots of fun stuff coming up. I'm going to be looking into, I'll give a little teaser. I was able to acquire a Sinclair portable computer. Sorry, not Sinclair. What am I talking about? All these big names in the industry back in the 80s are stuck in my head.
Yeah.
An Osborne One was what I meant to say. I found one in the box. It's not brand new. Someone repacked it after they had, moved on to something else. But it's in the box. I think it's got some receipts in there and some manuals and stuff. So we're going to explore the history of the Osborne 1, which is quite fascinating from a product development standpoint, as well as looking at the actual equipment and bringing out somebody's treasured computer that they bought back in the day and liked it so much that they kept it wrapped up neatly in a box and stored away someplace. So that'll be a lot of fun.
Yeah, that's great. That's great. All right, I appreciate you being here. And so coming up on the show in the future, next week, we have James Cole of the Firefly 3 project. And yes, that does imply that there was a Firefly 1 and a Firefly 2. It is personal finance and an open source project for tracking and visualizing personal finance, which I found very, very interesting. In fact, there's a decent chance that James will talk me into trying this out and using it to track some things. So that is next week on the 14th. After that, the schedule is open. So if you are a project or know of a project that you think needs to be on the show, you can let us know. floss@hackaday.com is the place to send an email, and we'll get that and get things scheduled or get people invited. Speaking of which, we do appreciate Hackaday as the home for Floss Weekly. And you can find more of my work there every Friday morning. I have a computer security column that goes live, and sure enjoy getting to do that. And if you want to follow me, you can do so there. There's also the Untitled Linux Show that's still over at twit.tv/ULS. You can find us there. Other than that, we just appreciate everyone that's here, those that watch, and those that listen, that get us live and on the download. And we'll be back next week for more Floss Weekly.